welcome to our new session. In this session, our focus will be on SDT340 LUBExpert Mode. This is a full integration of LUBExpert capability in the condition monitoring instrument SDT340. Of course, this opens a huge area of improvements and optimization, considering that now you can do condition monitoring and proactive condition-based lubrication at the same time, meaning connecting predictive and proactive. Of course, this opens an optimization of the tasks where practically a loop technician, while performing the proper greasing, can collect highly valuable condition monitoring data and vice versa. However, let's move to a short walkthrough before we start working in UAS3 as a preparation for a job in SDT340. So during this short walkthrough, I just want to show you what are the possibilities so you can better understand during the practical session. First move that you can do if you're already working with LUBExpert, that obviously you have a database that contains all your measurement points. Some call it your lube route. Now you will be able to transfer it into your SDT340 database. So the process is very simple. Open the new tree structure or the tree structure where you plan to do your lubrication and condition monitoring. Use this tool, the icon, to transfer, and then choose from which tree structure you want to transfer it. The entire tree structure with all necessary details will be transferred, and you can start building it for your SDT340 LUBExpert. From the sensor perspective, there are some important news as well. Now, for the LUBExpert function, the sensor that you will be using is named LubeSense/RS2T. The 340 instrument will recognize both LubeSense1 and RS2T and perform the lubrication process through LubeRate algorithm. RS2T will do the job both as LubeSense1/RS2T and RS2T itself, because RS2T we are using for condition monitoring, while LubeSense1 will only do the job as LubeSense1/RS2T, so only as a lubrication sensor. Now, very important that you will try later together on the UAS3 software is that measurement point can contain only one lubrication setting. This is quite straightforward because we will not lubricate the same bearing twice in the same session. So that means one LubeSense1 RS2T sensor in one measurement point. A LubeSense1 RS2T can be 32 kilosamples per second or 128 or extremely high resolution 256. In the same point, RS2T measurement point, RS2T can be added with the same or other sampling rate. This is how it looks in the software, where I have in one measurement point, I have both LubeSense lubrication and RS2T condition monitoring back to back, meaning I can do it in the same route. As you can see here, I have LubeSense 32 kilosamples per second, but I also have RS2T focus 128 kilosamples per second, probably because I want, in this case, to do condition-based lubrication, and after that I want to use high-resolution data for condition monitoring. However, I can do it all in the same time, as I will show you later in UAS3. So apart from the LubeSense1 sensor, I can use also other sensors like temperature, RS2T in all different resolutions. I can use my accelerometer or needle, so there are no restrictions from that side. That again emphasizes the combination of condition monitoring and condition-based lubrication in the same database with the same instrument. The settings are almost the same like they used to be in the LUBExpert. You can see our other sessions explaining that. So there will be a sensor name, sample rate, filter frequency, the measurement name, interval that is mandatory, needs to be entered, grease name, grease gun, bearing designation, both from the perspective of the size, but also to be more precise in the analysis for the fault frequencies, including the manufacturer, Both databases are available in US3. Rotating speed, of course, acquisition time will be defined based on minimum or recommended or any other time you want, but not less than minimum. And there is an important and interesting use, and that's choice that you can make about saving initial and final measurements only or saving all signals. I will explain it in details just in a second. SDT340 by default collects dynamic measurements, meaning time waveform and spectrum for each measurement. Now, when we are lubricating, we can choose to collect dynamic measurements of all steps in the process. That means that sometimes in the process we will have 3, 4, maybe 5 steps, and we can collect time waveform and spectrum from each step during the lubrication process. It is very valuable, especially when there is a potential defect on a bearing, and we can make analysis during the lubrication in each step and understanding how it behaves. However, sometimes it's not necessary, and in the case it's not necessary, maybe it's a better idea to use only initial and final, because if the operator lubricates 60, 70 or more bearings in one shift with an average of 5 steps, that will be a lot of measurements to download. It's not a problem with the memory, but definitely waiting for the download. It's not necessary if these measurements are not highly needed. It looks like this. You can see the initial measurement, initial reading. We have time waveform and spectrum and all the indicators, RMS max, RMS peak, and crest factor, as well as grease quantity in later stages. Each step in between contains the same information, time waveform and spectrum, and also the final one contains time waveform and spectrum. The other option is that we can choose initial and final step, and it will apply both to guided mode and the free mode, however you lubricate, in whichever mode you choose. The initial and final steps will contain dynamic measurement, while all the steps in between during the lubrication process will contain indicators, RMS max, RMS peak, and crest factor, therefore creating a trend during the lubrication process, as you can see in this screenshot from the software. So you can see the initial measurement, the first one, contains time waveform and spectrum. All the steps in between contain only indicators, and you can see in the upper right corner that the trend is full of the entire process. And the final measurement also contains time waveform and spectrum, basically giving you a full picture of the bearing condition before and after lubrication, the feature that can be very valuable during the analysis of the potential defect. Other settings, messages are as before, work orders as before, interval compliance indicators same as it was, alarms same as before, considering that, as you learned in previous sessions, lubrication will be triggered by RMS absolute alarm. You can refer to our previous sessions where you can see all the details about this, what is mentioned. Before you start, when you open your SDT340 and you have LUBEsense 1 connected, important feature to understand is that LUBEsense 1 in the free mode on 340 can be used only as a functional test, because lubrication process need certain presettings. In the free mode, we don't have these settings, so it can be used as a functional test. As you can see, if I choose the sensor, not the tree structure database, not the work order surveys, but choose sensor directly, I can do the measurement. The measurement will be collected. I can see the indicators, but I cannot save the measurement because this measurement with lubrication, for lubrication, cannot be performed in this way. The proper way is to use a tree mode, database, or work order or survey mode, which I certainly recommend, because in this case, the task is clearly defined before going into the field in the most ergonomic and most optimal way to walk around and take the measurement. The screen, once you select the LUBEsense 1 RS2T, gives you a lot of information that you need to know before you start. So the location, in this case fan, motor, non-drive, and bearing. It reminds you about the grease type you should be using at this point. Also, it reminds you about the grease gun you should be using at this point. There is a theoretical calculated quantity, certainly only as an information. There is an alarm information. So in this case, we can see that alarm is assigned to this point, and it's 45 dB microvolt. And what was the selected about saving the data? In this case, it's save all measurement, save all time waveform and spectrum during the entire process. The next step, as you can see in the bottom of the first screenshot, press enter to start initial measurement. We press enter and measurement is on the screen. All the settings are done before, the duration of the measurement. Now all we need to do is set up the amplification if necessary. In this case on the screen you see it's not necessary. Otherwise it will be a red arrow showing up or down. And we can press enter, save the measurement, and measurement is on the screen. Now for the moment you press enter to save the measurement, there are three possible scenarios that can happen. The first scenario is that in case that alarm is not assigned, you'll be notified about that, and you have a choice to choose guided mode if you want to lubricate, to choose free mode, to assign a message only, or simply to exit and consider this as a condition monitoring. You just want to collect data and see what is the condition of the bearing. The second scenario is that alarm is assigned, but lubrication is not needed, meaning that alarm was not triggered. This is clearly explained on the with the icon. But still, if you insist on adding grease, and sometimes there could be a good reason for that, you need to press F4 and you will be directed to the messages where you need to confirm that you want to add lubrication for whatever reason it is. And then you can go to the screen that will show you that you can choose guided mode or free mode. And the scenario number 3 is that alarm is assigned and triggered, and obviously lubrication is needed. Now you can choose guided mode or free mode or simply exit, but you will need to exit through the messages and confirm that you are willingly ignoring alarm and recommendation. In the first scenario, alarm not assigned, all options are available. You can add grease, assign a message, or simply exit. When alarm is assigned and not triggered, basically you exit, you're done. Or you can add grease, but only after adding messages. Or alarm is assigned and triggered, lubrication is needed. In this moment, in the background, the message is generated about lubrication being needed or not. And you should add grease. You choose guided mode or free mode, or exit, but only after adding a message that you are willingly ignoring the alarm. If you choose the guided mode, this is the screen that you will see. The screen shows you, of course, the location where you are, fan, motor, non-drive, and bearing. It shows you the alarm status. In this case, alarm is triggered. It shows you theoretical quantity, calculated quantity on the left side. It shows you already added quantity in this particular process on the right side. It shows you the main part of the screen is instructions. What should you do next? In this case, you should add 8 shots of grease or 9.6 grams and press enter. The current status, because this is the first step, is that the status is pending. We still haven't started lubricating yet. And there is an instruction that press escape as an emergency exit. This is what you probably remembered or seen in previous sessions from the LUBExpert. In case there is a huge back pressure that you feel on a grease gun, or there is a safety risk, something unplanned happened, or simply asset stop rotating, you should stop the process, press escape, and it will be declared as a process aborted. The status of each step will be shown at a place where now it says status pending. After adding grease and pressing enter, you can see that immediately in added quantity, it's already 9.6. The measurement is going through the stabilization time and measurement time. And after we follow step by step, you will have a final screen when the LUBExpert in 340 tells you the task is completed. Initial RMS was 59.3. The final RMS was 46.5. The total edit quantity in this process was 30 grams. It ended up as a lubrication success status. All you need to do now is to press enter to finish and move on to the next point. Emergency exit or aborting the process, you simply need to press escape, because the guided mode doesn't assume that you need to stop the process unless you say so. And once you press escape, you will see this on the screen. Are you sure you want to finish the process? And then if yes, it will direct you to the messages where you will assign the message that explains the reason why you are stopping the process. And the status of the bearing will be process aborted. It's important to have this red icon and the process aborted status, because whoever is looking at the software, if it's not you, needs to understand that the process was not completed, obviously for a good reason. In case you choose the free mode, readings are displayed in a bar graph numerically. Each measurement will show a new bar, and between them there will be temporary bars. So again, on the screen you have a location, fan, drive, and bearing. You have a theoretical quantity. You have added degrees up to this moment. The red bar shows initial reading. It's red because the alarm is triggered. And then we have floating bars that will be refreshed every 2 seconds before the next measurement. So that's the time while you are adding grease. And during that time, you can see the development. What is the reaction of the bearing while you are adding grease? Once you finish adding grease, you will press enter. The measurement will be collected through the stabilization time and the measurement time. And once that measurement is completed, to stop you from forgetting, as I did many times, you will be required to enter the number of shots that you've added in this step. You just press how many shots you added, 3, 4, 5, and press enter. After that, the measurement that you have just taken, the step you have just finished, will be displayed on the screen, and the new floating bars will start emerging while you are adding the grease for the next step. And step by step, in the same way. And at one moment, when you see the deflection, the measurement starts creeping up, then it's moment to stop, and that will be F4, but you will stop the process. Remember, in the free mode, you are the one to stop the process, not like in a guided mode. And you will have a summary screen in the end where it says that the task is completed. There is initial measurement, final measurement, total edit quantity, and the status lubrication success. What you need to do now is press enter, and it will automatically move you to the next point in your route. After that, all that you need to do is come back to the office, and after the coffee, you just download the data into UAS free. And from that moment, we will learn how to work in UAS free. Now, as a next step, let's see how it works in practice. Okay, now we will start working in UAS free. We will focus only on the features that are in connection with the SDT340 LUBExpert, because all the other features are explained in the previous videos. So here I have a small database, motor pump that has a motor and a pump, 2 bearings on the motor, 2 bearings on the pump, and a pump casing that I usually take the measurement to locate a cavitation. So let's make few settings on the motor. On the drive end bearing, you'll set add new measurement setting, and we will choose for lubrication, in this case, LUBEsense 1 RS2T. What I can choose now is a sample rate. 32 kilosamples per second is more than enough for lubrication, but if you want to use the same measurement for the condition monitoring, for the deeper analysis, I would suggest to take 128. So let's take 128 in this case. We need to define the interval. Let's just say 1 month. Then we need to add a grease lane. It's going to be Unirex. Grease gun, let's say red, with the output of 1.2 grams per shot. We choose the bearing. Let's say it's 6317. And we will choose the same bearing for the analysis. And let's say that manufacturer is NSK. Rotating speed, let's say 2,985 RPM. Side replenishment, and we can choose recommended or minimum time, or write any other time. As you can see, as you know from previous training sessions, we'll just choose recommended. And now we can select either we want to save initial and final signals only, or we want to save all of the signals. Let's take all the signals in this particular case. And our settings are done. Just press save. And we have our first measurement setting on this particular point. But at this point, I'm also doing the condition monitoring. Even though my 128 kilosamples per second measurement will be more than enough for condition monitoring, just to show you that it's possible, I will also add RS2T, and I will add it, let's say, like the exaggerate to 256, the measurement 5 seconds, interval 1 month. The bearing and the speed is already added because I already defined it in the previous sensor. I can also add accelerometer. I can add 10 hertz to 10 kilohertz. I will also take the measurement every month. The bearing is already there, and basically we are done. We can do the same thing on drive end bearing. We can add other sensors as well, or we can just leave one sensor, LUBEsense, and collect all the data during the lubrication. Now we will add this point or other points to the work order. So I will add motor. Let me just set additional measurements. RS2T, LUBEsense, 1 month, Unirex, red, 2985, recommended time, and just add bearing. This one, recommended time, save. In this case, let's put save initial and final signals only, just to see the difference, and save. Now we can add motor into the work order survey. We'll call it motor. Now the settings for my motor are now done. And as you can see, I have different sensors. I have accelerometer, RS2T, I have my lubrication. Here 128 kilosamples. Here I have it in 32 kilosamples. I can also add another measurement, which will be RS2T. In this case, I chose the lubrication in 32 kilosamples. Now I can go higher here. 1 month, the bearing is added. So we are done. I will just refresh my work order. And here we are. The motor is ready. And what we need to do now is to send it to the new work order. Normally, when you're building the database, there will be much more points. I'm using just 2 points now, just to show you how to perform. And the work order is now defined. We'll go in this order. If I want, I can go drag and drop and change the sequence. And next thing we need to do is to go lubricate. And here we are. We uploaded our database and surveys into SDT340. Now we are in the field. I connected my RS2T sensor because I will do also other measurements with RS2T, so I do not necessarily need the LUBEsense. The lubrication process will be triggered. Then I will choose my work order that we predefined, motor. When I select the motor, my first point is motor non-drive end, lubrication, and I will press enter. Once I press enter, I have a descriptor telling me where should I be, which grease I should use, which grease guide I should use, what is the adjusted theoretical quantity of grease, what is the alarm setting, and what did I select about the saving. In this case, I selected to save all measurements, all steps, time, waveform, and spectrum. Once I confirmed, I'm in the measurement screen. Now I have to adjust, if necessary, amplification. You can see if I over-amplify it, I will be warned by a red arrow. I set up the amplification and I will take the initial measurement. I see the progress of the measurement on the screen. The measurement is displayed. I see the indicators when I save the measurement. Considering that I have the alarm assigned and alarm is triggered, I'm suggested that lubrication is needed. Alarm is triggered. So I can choose guided mode, free mode, or I can choose exit. If I choose to exit and not to lubricate, meaning ignore the alarm and recommendation, I will need to add message, which will be set as a manual message. Yes, you have learned that in previous sessions. So there will be a tracing that I was suggested to lubricate, but I did not. First, now let's choose the guided mode. Guided mode will completely guide me through the process. And as you can see right now, I can see the zero grease is added. And I'm instructed to add 7 shots of grease and press enter. I can press escape and exit the process at any moment in case of the emergency that we will discuss later. So right now, let me put 7 shots. I'm working on a simulator, so I just press 1 button, not 7. And I press enter. Now we are in a stabilization time. Measurement is not yet being taken. Stabilization time is over, and now there is a measurement time. Status is pending because we still don't have a status. Measurement is saved. And the status right now is lubrication success. I'm instructed to put 4 more shots of grease and press enter. From now on, I will, in guided mode, follow the instructions until I'm stopped. The instruction will be that the task is completed. For the moment, everything is going fine. So this step says no change, but I'm instructed to add more grease. So I will add more grease and press enter. And this way I will be following instructions step by step. Now another measurement is being taken, saved. Status is lubrication success. Add 3 more shots. Adding 3 more shots and pressing enter. Now the next measurement is being collected. Status is lubrication success. I'm instructed to add 3 more shots of grease and press enter. Next measurement is being taken. Okay, lubrication success. So the signal is going in the right direction. Add 3 more shots and press enter. Another measurement is being collected. And we are done. Task completed. We have a measurement initial, we have a final measurement, added degrees or quantity, lubrication outcome is lubrication success, and I'm instructed to press enter to proceed with my work. As you can see in the survey mode list, I have a lubrication status, it's green, so I'll just continue with the next sensor, which is RS2T. I'm not doing lubrication. So I will select my sensor. This is, let's say, my regular condition monitoring task. I will set up the amplification and I will take the measurement. It goes smooth without changing the sensor. If I'm in the same position, I'm not even moving the sensor at all. It stays where it is. I'll press enter, save the measurement, and move on to the next one. Next one is accelerometer. I'll not put it right now. Let's go to the next point, which is drive end. Drive end lubrication. I will press enter to enter my lubrication scenario. Let me just change the signal a little bit. Okay. I'm entering the process. I'm instructed to take the initial measurement. Measurement is collected and displayed. I press enter. Alarm is not assigned at this point, so I can choose whatever I want to do. Let me choose the free mode, so you can see both. What you see now generating after the first measurement are floating bars, so telling me what's happening right now. I will add 5 shots of grease and press enter. You can see immediately bars showing me that it's going in a good direction while I'm adding the grease. And I will take the next measurement. So the floating bars will be appearing between each 2 measurements. Now I need to say how much grease I added. 1, 2, 3, 4, 5. Press enter. I see the second bar. So it was successful, obviously. And the new floating bars are appearing. I'm adding more grease. And press enter. Below the graph, I can see initial, previous, and current measurement. So you always see in the numeric expression where did you start from. Okay, I added 4 shots, please. I'm acknowledging that. Press enter. This is my third measurement. And the floating bars are going to start to appear immediately. Now I will add another 3 shots of grease. You can see the change. And press enter. In the free mode, you can stop the process anytime you want, but you have information. You can add as much grease as you want as well, but you have information on the screen. You understand what is the response of the bearing for the behavior of the signal. I enter the quantity of grease I added. So it's going in a good direction. Floating bars are appearing again. I will add in each step less and less grease, call it fine tuning. So I'm adding more grease, press enter. and the measurement for this step. I added 2 shots of grease. Enter. So everything is going in a good direction, so I have no reason to stop. I will add 2 more shots of grease, following the floating bars, and press enter. Two shots, enter. We still have correct change. Now I will add 2 more shots. And what I can see, it starts growing up. I'll stop adding grease. Enter, press enter to start the measurement. Measurement is being taken. I added 2 shots of grease. Press enter. And what I can see on the screen is that signal deflected is going up. So I will stop the process. I will stop the process, confirm, yes, measurements are saved. And we are in the final screen, lubrication success, initial measurement, final measurement, task completion, quantity of added grease. We acknowledge, press enter, and we continue with whatever is now next in our work order survey. Let me go back up to the non-drive end again to show you another possible scenario. So let me stop the signal and change it. So now I'm back on the non-drive end. Let's assume it has been a month. We are back again to take the measurement. So I see the descriptor. I have all I need with me, and I will press enter. And I'm in the measurement screen. I have to increase the amplification. And take the measurement. So now I'm taking the initial measurement. Don't forget, at this point I have alarm assigned. Here is my measurement. And instructions say do not lubricate, because there's no need. Alarm is not triggered. The signal is in a very low level. Now I would normally press escape, exit, and finish. But let's just see what happens if I insist on adding grease. It will take me to the messages, and I will select the message that says lubrication needed. Let's call it my decision. So I added this message because I think that lubrication is needed, that decision can be justified or sometimes unjustified. And I will choose free mode, which is always recommended when you are against the recommendation. And you can see the first bar is green, so alarm is not triggered. Let me add 5 shots of grease and see what happens. Nothing good, fortunately. And I will press enter. The measurement is being taken. Added 5 shots of grease. Press enter. And I can see that it's definitely not good. I will press F4, exit, end the process. The process says over lubrication. So I'll press enter and move on to the next point. Let me move down again to the drive end. Let's assume it has been a month. So let's put another signal on. Press enter. Adjust the amplification to the signal. On this one, I have no alarm. And I can choose what I want to do. So let's assume I choose a guided mode in this case. I should add 7 shots and press enter. And now I want to show you what happens if something unpredictable and undesirable happens. Let's say the machine stops right now. The possibility is that there is a safety risk. I see that the grease line is loose or whatever else, or I feel the back pressure when I try adding grease. I will press enter. Yes, I want to abort the process. And I need to add a message. Let me add, say, safety risk. Yes, I confirm. And I'm out. Process status of the bearing is process aborted. I didn't add any grease. Just notice something is wrong, and I just exit the process. Now let's upload this to the software and see how it looks like when we upload the data back. And we are now back. We downloaded the data from SDT340 to US3. Now let's take a look at the data a little bit. So what we lubricated was no drive end and drive end bearings on the motor. Now you can see that there is a red oil drop icon on the pump and on the motor because of the drive end bearing, and that is because of the status of lubrication. And the reason is that it was process aborted and the safety risk. Here you can see that this is the message we added, safety risk, and this icon in the red will stay for as long as there is no new measurement. So somebody actually visited the site and removed the problem that was declared as a safety risk. Now let's focus on lubrication a little bit more. All these explanations exist in other training modules. So if we click on the LUBExpert lubrication, we did 2 processes. In the first process, we were using guided mode, as it's shown here. There is no letter F. And we had made 6 steps. Before, in LUBExpert, you only had first and last in guided mode. Now you can see here that you have all the steps. Your trend shows entire process. So here is the process number 1. So you can see step by step. You can actually see the numbers in the graph for each step. What was the signal and how much grease was added at that point. Let me just remove them so we have more space. And now we selected, as you probably remember, we selected to save all signals. Here is the initial signal. The status was warning because an alarm was triggered. And we can see it here, the alarm was triggered. And we have a time waveform and spectrum. And after that, for each step along the process, we have a time waveform and spectrum. So if there is a potential problem, we can do analysis based on initial, based on final, compare them. But we can also see the evolution of the signal during the lubrication, especially if we have a defect, known defect on the bearing. That would be a really good idea to do, and it's highly valuable to understand what comes to what side. Our second process was this one. Let me just show you again. In the first process, we took initial measurement, and immediately after that, there was automatic message lubrication needed. That's what we saw on the screen. We didn't add the message, but that message was added in the background. Then we followed the process through. This is the quantity grease we added, so everything basically went fine. After that, we went into this second process. You can see here that the status was normal and the message added in the background was lubrication not needed, automatic message. A couple of seconds after that, I added manual message lubrication needed. I override the recommendation and alarm, ignore them basically, and start lubricating. I was lubricating in a free mode. That's what this letter F here means. And after one step and 6 shots of grease, it was over lubrication. What we can see here as a rise of the signal, still in normal, still below the alarm, but definitely not a good idea to do. As you can see in the first process, we can see the quantity of grease added in each step, which is quite important so we can understand was the process done properly or not, especially if we are doing it in a free mode. Let's go to another bearing where we didn't have the alarm. That means there is no alarm status and level name. There is no automatic messages, but this was done a complete process, basically same like the previous one on the drive-in, was done in the free mode. And here we can see that we were adding grease in steps 7, 4, 3, 2, 2, and then we finish the process. So gradually decreasing in quantity of grease in each step. And here you can see that we have a time waveform spectrum for initial measurement, condition before. We have a time waveform spectrum in the final step, condition after, and in between we have indicators. Those indicators are actually shown here in the graph. We don't need, in this particular case, if we decide so, we don't need time waveform spectrum for each of them. Before and after will be enough. The next process we took after that was this. We started with the initial measurement, and then we decided to go with a guided mode. Unfortunately, just mimicking the possible situation, we noticed some safety problem. We aborted the process, and immediately after that, it's mandatory to add the message. In this case, it was safety risk. It's a manual message. So whoever needs to understand what happened will have a message here, and he needs to visit the bearing. Also here, if we go back to the no drive-in bearing, we did lubrication, but we also did, we collected the data coming from RS2T as a condition monitoring. Now there are multiple combinations where we can connect lubrication and condition monitoring. In most of the cases, doing lubrication this way in this resolution means that's enough. We have everything we need for condition monitoring, and the task will be done by one person in the field. If we need more data, if we will do the lubrication in a low resolution, we can still set up the sensor like I did here in a higher resolution, and the same person, without even moving the sensor, will do the job immediately after lubrication. So this is what I mentioned before about the optimization. Now when we talk about each point, no drive-in bearing, we can have all the data here. Lubrication, condition monitoring, I can add vibration, I can add temperature, RPM, everything will be in one place. It will be transferred in one word order, where we can send somebody to both lubricate and collect condition monitoring data in one route. It's highly optimized system, and what is most important, it offers huge amount of high quality data while the job is done equally as it was done before. No additional man hours, no additional instruments, no additional route going in the field. I hope this helped. I hope this training helped you to understand more how to use this instrument and those new features, LUBExpert integration in SDT340. So if you might have any other questions, feel free to call anyone from our team. Thank you for your time.